Hey everyone, this is Nick Diobertis teaching you financial modeling. Today we're going to be going over the lab exercise on applying Monte Carlo simulation to the dividend discount model. This is part of our lecture series on Monte Carlo simulation. So we have already introduced what Monte Carlo simulation is, and then we went and applied it in the context of a portfolio model, choosing between two different assets. And now we're reaching the lab exercise at the end of that material, and it's focused on the dividend discount model. So the situation here is that you're trying to value a mature company. They have stable dividend growth, and so this is a reasonable model to look at for valuation. And the model is defined as you see here in the second point. The price is equal to the next dividend over the cost of capital or discount rate of the stock minus the growth rate of the dividends on stock. And I gave you the initial values to use for the inputs. So the next dividend is going to be $1. The discount rate, cost of capital, is going to be 9%. And the growth rate is going to be 4%. So the first step here is just to build out the core model, which is able to take these inputs and produce the price from those inputs. But then as the modeler, you're concerned that some of these inputs could have been misestimated. Maybe the growth isn't 4%, maybe the cost of capital isn't 9%. So how can we evaluate changing these and understand what are the chances of achieving different prices based on the possibility that these values could be different? That's where the Monte Carlo simulation comes in. So for the level 1 exercise, we're going to take the growth rate and now draw that from a normal distribution with a mean of 4%, standard deviation of 1%, and run that through the simulations, and ultimately visualize and summarize the resulting probability distribution of the price. And then coming to the level 2 exercise, it's going to be continuing on from the first, but here you're just also concerned that the cost of capital could be misestimated. So for that, we'll also be drawing from normal distributions using a mean of 9%, standard deviation of 2%, and the growth is also being randomly drawn at the same time. And then we want to run through the simulations and visualize and summarize the resulting probability distribution of the price. And now you have to be careful in this level 2 exercise that there is a condition in the dividend discount model for it to be valid. When we look at the dividend discount model, we have this denominator, the cost of capital minus the growth rate. For the model to be valid, the cost of capital has to be greater than the growth rate. Otherwise, this denominator becomes negative, the price becomes negative, which is nonsensical. So that's actually an assumption of the dividend discount model that the cost of capital should be greater than the growth rate. And as you're doing the level 1, it's pretty unlikely that that situation would occur, that the growth rate would be greater than the cost of capital. Because we're drawing with a mean of 4%, standard deviation of 1%, it's pretty unlikely that it's going to hit 9%. But then once we start also varying the cost of capital, now if we happen to get a low cost of capital at the same time we're getting a high growth rate, then that would lead to this condition, or a violation of the assumptions of the model, that the cost of capital should be greater than the growth rate. And then you'll get negative crazy prices in your model. So what you need to do in addition to building the base model and building the simulation is you need to be able to check the simulation inputs before passing it through the model. And you want to check that the cost of capital is indeed greater than the growth rate. And if not, just reject that simulation. You want to draw new inputs because it's not a valid run of the model. So that's the overview of the lab exercise on adding Monte Carlo simulation to a dividend discount model. So thanks for listening and see you next time.